Today, I want to show you how to use Energimise to design a solar energy system. To create a project, you need to select a location by using latitude and longitude or by searching an address. Here, I enter a postcode and then, by clicking on the address, it shows the area on the map. Also, if you enter the latitude and longitude, you need to press the search icon to see the area on the map. Then you need to select a roof type. Here are 6 different types, and you need to select the nearest to the project roof. If I select this one, which has 2 sides, I need to enter the information of both sides. And if I select, for example, this one, I need to enter all the information for 4 sides. The first question is if we know how many panels can be installed on the roof. We can choose yes if we know. Then we only need to enter the number of panels. For example, 8. And the pitch or slope of the roof 45 degrees. Now, we must click on the Save button and it changes to green. Then the information of the second side must be saved. If we don't know how many panels can be installed on each side, we can choose No here. Energimise has a function that calculates the number of panels. Here we need again to enter the pitch and then the dimension of the roof. For example, if side 1 is 6 and 5 meters, then I can enter. And if there is any unusable area, like a chimney, we need to tick this box that shows we have an unusable area in this side. And then we need to enter the dimension of it, for example, dimension of the chimney. If our chimney is 1 meter to 1 meter and the distance from the left side of the roof is 3 meters and the distance from the bottom of the roof is 2 meters, you can see the unusable area here. 3 meters to the left, 2 meters from the bottom. It shows where the unusable area roughly located, and then we need to save this. The second side, without any unusable areas. The next thing we need to specify is the building orientation. We can use the map to select the orientation of the building. If you click here, you can change it to match the direction with what we can see on the map. Please note that these numbers shows here is the side's number. The first side we entered the information, the side with a chimney was number 1. And this one without any unusual area was number 2. So it is important that when you select the orientation, you consider these numbers. For example, if the chimney is in that side of the house, you need to change it like this. So here the house orientation is like this. This is the first side, and this is the second side. And the chimney is in that side of the house. In step 2, we are going to choose the grid specification and electricity tariff. First, we can select the currency. Then, we need to select the connection type. It can be grid connected or standalone. If we select the standalone, we only need to specify the desirable reliability. For example, if you enter 99, it means 1% of total electrical load can be unmet. In other terms, 1% blackout is acceptable. Sometimes the desirable reliability can't be reached with the maximum number of panels that can be installed on the roof. In this case, you will receive an error that asks you to reduce the desirable reliability. This is all the required info for the standalone. If we select the grid connected, purchase price of excess energy must be entered. When power output of PV panels is higher than demand, this excess energy can be delivered to the utility grid, and provider might purchase it with an agreed price. There are 2 options for the grid connected: weak grid for those grids with frequent power outages and reliable grid. First, I choose reliable grid. Now, I need to choose the electricity tariff type. Fixed price, that is a fixed price for all the times. For variable price, there are 2 options. Multi-step tariff is a type of electricity tariff, which the price will be different based on the monthly power consumption. In the table, for example, we can enter electricity tariff for the monthly consumption less than 100 kilowatt-hours is 50 cents per kilowatt-hours, and for excess than 100 is 80 cents. We can't edit the first column, monthly consumption, from but the other two columns must be fill out based on your project's info. We can enter up to 3 steps from 0 to 10,000 kilowatt hours. Peak/off-peak tariff or economy 7 is another type of electricity tariff, which has different prices for peak and off-peak times. We can enter up to 3 different prices for different time intervals, without overlap. End time must be higher than start time, and electricity tariff for the rest of the times must be entered. Here, I enter electricity tariff from 10 to 15 is 30 cents per kilowatt hours, and for the rest of the times is 50 cents per kilowatt hours. Please note that it includes 10 and 15. That's it, all we need to set up for a solar system connected to a reliable grid. However, if we select a weak grid here, we need to provide some more information. Number of outages in 1 month, in average, for example 5 outage occurs every month, where the average duration of each outage is 4 hours. Also, here we have 2 options for controlling the system: maximum self-consumption and backup mode. Please check our website for the difference between those methods. The other question we need to answer is if there are any power limitation in the peak hours. If we choose yes, we need to enter at least 1 power limitations. For example, from 18 to 22, maximum power that can import from the grid is 3 kilowatt hours. That's it, we are ready to go to the next step. In step 3, we must provide the power consumption or electrical demand data. First, we need to select a time zone. Then, if we have the hourly power consumption of the project for 1 year, it means 8,760 samples, we can upload it as an Excel file. If you have data for a few months, you need to manipulate the data for the rest of the year, and then upload the dataset. Please read the file requirements before you upload the Excel file. If we don't have the data, we must select a pattern for daily power consumption. For example, evening activities is suitable for households who work outside during daytime or they use energy mostly in the evening. The next question is if we know monthly power consumptions for 12 months. Monthly power consumptions in kilowatt hours must be entered for all 12 months. If we select no, we need to select a monthly pattern. For example, cooling is suitable for countries with hot summer and mild winter. And the last question here is the total annual power consumption in kilowatt hours. Please note that providing detailed information here will result in more accurate and optimal design. Step 4 is about the solar system components. First, we need to select if we want to design a PV and battery energy system or a PV-only system. Then we must provide the information of the PV panel. We can choose a brand and a model from the database or fill out all the field by ourselves. If I select from the database, you can see it fill out all the field except power loss and price automatically. Power loss must include all the power loss such as cabling, heating, shading, etc. Then we need to enter the information of the battery, battery charge controller, and inverter. If you need more details, please check our website for the definition of each field. After we entered all the required information, we can review them in step 5. Like what we can see here. If we need to modify any fields, we should click on the Edit button and it directs us to the relevant page. When we click on Next button, this window asks us to fill out some personal information like name and email address. You can support us by ticking this box and let us send you technical updates and marketing emails. By clicking on Final Result, you can see the optimal design in page 6. Please note that it can take up to 5 minutes to find the best design for your project. Finally, step 6 presents the optimal results for your project in 2 scenarios. In the first scenario, optimal size of PV panels and batteries are calculated so that you have the minimum total cost over the project lifetime. In the second scenario, up to 10% more total cost than first scenario is allowable if it can find a system with less capital or initial cost. This is a good option when you want to spend less at the beginning. Here you can see the project summary. And then this table is the result. First column shows the electricity bill and carbon emission of the house without having a solar energy system. You can use the information for any financial analysis. Second and third columns are the results of the first and second scenarios. For example, here, first scenario suggests 16 panels and 64 battery units as an optimal design, although second scenario suggests 18 panels and 36 batteries. Also, you can see while the total cost of the second scenario is 10% higher than the first scenario, the initial cost of the second scenario is 20% less. Please note that the carbon emission can be negative when your solar energy system delivers clean energy to the utility grid.